Okay, um, we're going to start actually with Reggie explaining how you find the calculator in Proctorio because it's not something that I have access to. You have to be a student and I'm not one. So can you explain?
Okay. Yeah, so pretty much there's like that little window that's for my computer, it was on the top left, that has your video image. And underneath that, there's like 4 or 5 buttons. One of them is kind of the universal symbol of a calculator. And you just click on that. And it was kind of weird because it's sort of like stores the numbers that you're inputting without really you asking it to. So you have to like really make sure you're clearing it in between functions. But that's where it is.
Okay, so again, hopefully that will help everybody. Again, one of the weird things about Proctorio is that only students have access to it, which means I can't play with it. So that's why I asked you to find out because I can't go and look to find the calculator because I can't even get in. I can set up Proctorio for you guys, but I can't get in. It's weird. One thing I don't like about it. Whereas Canvas, actually, I can see a student view, but I can't get a student view with the Proctorio setting.
Larry, is there any way that we can because I thought this was going to be our warm up. You know, we can't figure out these things within the 20 minutes, so we have to take the quiz.
So you want another chance at it?
Well, I mean, maybe just something that we can play around with and kind of figure out the look at the program. You know, maybe
all right, what
something like that.
What I'm going to do, and don't get scared about this. I'm going to set up another quiz. It'll be 5 hours long. Sound good? It'll be 0.01 points, which is basically nothing. Hopefully you're good enough at math to know that if you lose 0.01 points on a quiz, it means nothing. Are you good with that?
Yeah, that sounds great. Great to me.
Yeah, and I'll do that. I'll have to do it after class because I want to, teach and stuff first. And then after, I'll set that up, and you'll have the whole week to do it. Okay, and then you can play with it. Just to let you know, I am the only person that can see the recording. Okay, it is not available to anybody else in the world, including yourself, by the way. You can't even see your own recording. So there is security there, and it is an HTTP. It is a secured channel, which means that you have to solve the P versus NP problem in order to figure out how to get in. And by the way, you do that, you get $5 million. There is an award for that, and you ruin the world. So don't solve that problem. Everyone thinks it's unsolvable. So I can't get into the math. It's way too hard. But I will let you know that that I have worked on it, and I did not get the $5 million. So no, you can't. You can't get in. Another thing, and this is I saw in the chat box, is that I have to set the time limit to the maximum time anybody can get on the quiz or the exam. Okay, if I don't do that, then Proctorio, if I don't have a time limit, then Proctorio doesn't let me do this. So I have to set the time limit to the maximum time for all accommodations. So there could be some people with accommodations because of a disability. And so that's why the time limit looks longer. Okay, but there's a deadline to take it for you, but the time limit looks longer. So don't let that fool you. Does that make sense?
Okay. I have a question as well, if I can ask real quick.
Sure.
I used my calculator, but I flashed it in front of the screen.
That's not okay. No, you're not allowed to use your calculator.
Okay. And then also,
now, I'm not gonna do anything on the quiz, but it won't be okay on the exam. Got it?
Okay, so I'm supposed to use just the applications that are in the doc.
Right, because the problem is that a calculator. You got a calculator. You're doing this. They don't know if it's a smartphone. Okay. Do you see? Because it's not on the screen the whole time, and I can't let you do a smartphone. So it does a red flag that you're using a smartphone or you might be using a smartphone.
Okay, so are we expected to do all of our calculations online in that box?
Yeah, everything has to be online. And there won't, like this one didn't have many calculations. There's nothing to do. I mean, hopefully you can do 4 minus 2 in your head.
Yeah, but it's just messy to be writing everything in there.
Yeah, you're gonna have to write stuff down. But it, you don't have to write every single calculation if it's just an easy thing. You know what I mean?
Okay, so I can't be using like scratch paper to do something on the side.
I won't see your scratch paper as a problem.
So we're not allowed to use it.
Yeah, you can use it, but you won't get points for it.
Oh,
No credit will
okay.
be given, which means you're not showing work. And if you're not showing work, then you don't get points.
Okay. But if we're like, looking at a paper down here with our hands obviously doing something
You have
that
to show the paper at the
previously
very
said.
beginning of the test. You show
Okay.
it, show that it's blank, and then you put it down.
Okay.
And then
Sounds good.
Proctorio let you, then there won't be a red flag.
Okay.
That's how it works. The red flag happens, and then I see what happens. Does that make sense?
Mhm.
But these are good questions. And again, this is why I did it now instead of the test. Because I wanted to make sure that you got a sense on how Proctorio works before it actually means something. Okay. And as I mentioned many times, the quizzes don't mean anything in terms of points. There are points there, but it's really light. Whereas they do mean something in terms of figuring out whether you've learned the material. Okay, whether you can do it.
My Zoom keeps saying this meeting is being recorded like every couple of seconds. Is this happening for anyone else?
Huh. Okay, I can't tell you, but I do want to apologize.
I'm not hearing anything.
Okay, yeah, I'm not seeing it either. I do want to apologize that Monday's lecture, I don't know what happened, but about 10 minutes into it, I got a little message saying the recording has stopped. And then I hit the start button to start the recording. But then after I did that, it didn't record. And I have no idea. It said it was recording, and then I didn't get the email with the file to record. So unfortunately, the lecture from Monday, you only got the first 10 minutes on YouTube. So I apologize for that. I have no idea what happens. Never happened before. And we had COVID last quarter too. So let's hope it never happens again. So again, I apologize, but it didn't get recorded, and that's called technology. Stuff happens, right? So hopefully bad stuff doesn't happen, too often. But I apologize for that. So if you go to YouTube, you're only going to see the first, I think it's 8 minutes or something like that. Hopefully that'll never happen again. This will get recorded, and I'll be able to post on YouTube, and you'll see the whole thing. Okay, let me get to the quiz. I'm going to go pretty quickly because the quiz is supposed to be pretty easy. So basically, we want to look at this, see if it's continuous or not. And if it's not continuous, we have to give the reason. Okay, so let's start out with f of x equals 4 minus x if x is less than or equal to 2, 3 plus x if x is greater than 2 at x equals 2. So what's the first thing we should do? Always on limit. Yeah, first thing we should do is plug in. If you plug in 2, 4 minus 2, I hope you don't need a calculator for that, but you have one, if you know how to use it on Proctorio. 4 minus 2 is 2. How about 3 plus 2?
5.
5. Okay, so the limit on the left is 2. Is 2. The limit on the right, so let's write this out. So A, the limit from the left is B better, goes to 2. And the limit from the right goes to 5. So what do we say about the limit?
It's not continuous.
Yeah, I mean, that's right. The limit doesn't exist, not continuous. And by the way, I didn't show you this before. ETS is what I'll always write for continuous when I'm in a hurry. And you're allowed to use that too. So it's not continuous. What kind of discontinuity is it when the limit on the left and the limit on the right are different, but they actually exist?
Jump?
What's the word? Yeah, that's a jump.
Non-removable.
So there is.
Is it non-removable?
It's not removed, but we called it a jump, is what we did in the lecture. Jump discontinuity. Because it jumps from left to right. Okay, B. Okay, B. Now we're looking at x equals 0. What is the cosine of 0?
1.
1. What's 1 plus 0? Please don't get your calculators
1.
out. 1. So now the limit on the left equals the limit on the right, and because of this less than or equal to sign, it also agrees at the value of 0. So the limit goes to 1, and f of 0 equals 1. So what can we say?
It's continuous.
Thus, f is continuous at x equals 0. Okay, and in fact, everywhere. Okay, let's go C. Okay, so now we have, if it is not equal to -1, then it's x squared. If it is equal to -1, it's 0. And we want to find a limit at 0. So what did we get?
Would you have to substitute 0 for x squared?
Hmm?
Would you have to substitute 0 for x and square
Yeah.
that?
Mm-hmm. So what can we say? So at x equals 0, whoops, I should write C. At x equals 0, the key on this one is the issue is not at 0 for this function. F of x is equal to 0. Okay, that bottom part is actually not even significant. And I wanted to emphasize that. Most functions are continuous almost everywhere. Okay, so there's a problem at -1, but there's no problem at 0. And x squared has a limit 0 from both at 0. So f is continuous at 0. Any questions on that? Okay, at x equals -1, it's not continuous, but that's not what this says. So I wanted to emphasize that for piecewise functions, usually there's no problem as long as you're off that break. Okay, let's look at number 2. Okay, now we want to determine if the intermediate value theorem applies for each of the following and explain. So let f of x equal x squared minus cosine of x. Then f of x has at least one root between x equals -2 and x equals 2. So what do we have to do for part A? What are we looking for to check the intermediate value theorem? Okay, first is f continuous? Is it continuous? Are there any issues with x squared minus cosine x? What do you think? Are there any issues with x squared? Is x squared a continuous function?
No. And yes.
Think again, right? X squared is a continuous function. It's just x times x, just polynomials. And polynomials are continuous. Cosine of x is continuous, nice smooth. It just goes up and down. There's no breaks, there's no holes, no asymptotes, and subtracting doesn't change anything. So f of x is continuous. Now we need to look at f of -2. And notice f of -2 is 4 minus something small. Okay, cosine is never bigger than 1, never smaller than -1. So f of -2 is greater than 0. Let's look at f of 2. Well, that's also 4 minus something small. That's also greater than 0. Does the intermediate value theorem apply? Okay, it doesn't because 0 is not between f of 2 and f of negative 2. So the IVT, intermediate value theorem, does not apply. Remember, a root means 0, right? Means you're supposed to get 0. So that's part A. Okay, part B. Let's suppose f of x equals x to the 4th plus 5x minus 2. Okay, first, is that continuous?
Yes.
Yeah, it's a polynomial. Polynomials are continuous. No problems with them. So it's continuous. Let's look at f of 0. And that is equal to negative 2. And let's look at f of 1. I tried to do easy ones, so you didn't need a calculator. F of 1, that's 1 plus 5 minus 2, which is,
3.
it's actually,
Sorry, 4.
okay, 1 plus 5 is 6, minus 2 is 4, right? At least I hope you don't need a calculator. Okay. All right, is 2 between negative 2 and 4? Sure. So the intermediate value theorem applies. Any questions on part B? C. Okay, f of x is 5x over x minus 3. Then there exists a number c between 2 and 6, such that f of c equals 4. Is f continuous between 2 and 6? What do y'all think?
No.
No, it's a problem. There's a problem at 3. Do you see that? So f of x is not continuous. In particular, at x equals 3, which is between 2 and 6. So the IVT does not apply. Any questions on the quiz? Any questions? Okay, let's move on. And now, as hard as Proctorio was, what we're doing now is much harder. Just let you know that. In fact, it was the hardest piece of math I ever had to do when I was in high school. I had a different experience than anyone I've ever met in high school. I got to calculus, unlike our high school here. There were no teachers that knew calculus, but I was ready for calculus. So they said, just go to a room by yourself and learn by yourself. If you have questions, don't bother. And I had to try and learn this myself. I was so lost. So I'll let you know, I'll be here for you. Doesn't mean you won't be lost, but at least I'll help you out. So I will let you know that this is hard, and if you don't fully understand it, it doesn't mean you're going to fail the class. It might mean that you'll get one problem wrong on the test, and that's about it. So that's a big heads up. So first thing, we want to think about what does it mean to have a limit? And we've talked about limits kind of in general. If you run from the left and you run from the right, you're going to be able to say hi to your friend. Does that sound like a formal mathematical definition? Okay, hopefully you know that's not how mathematicians define things. Okay, it's good for the good feel of things, but that does not work as a definition. So the bad news is, to truly get a definition, it's hard. So I'm going to show you the definition. You may not fully understand it. Then there's a nice little app that I found, and we'll look at that. That kind of helps you see the definition, maybe. And we'll play with it, and then we'll use the definition to prove things have a limit or prove things don't have a limit. So that's going to be the plan. So let me show you the definition, and just want you to know it's hard. So we'll see. Okay, and it's really hard to use for anything complicated. Okay, so here's the definition. So the definition is x approaches some number, c is a number, of a function f of x is equal to a number L, okay, which you usually call L, standing for limit, if for any epsilon, that's how you pronounce this letter, this is a Greek letter, greater than 0, there exists a delta greater than 0. Okay, and delta, that's a Greek letter too, greater than 0, such that if the absolute value of x minus c is less than delta, then the absolute value of f of x minus L is less than epsilon. Okay, my guess, you were all thinking, yeah, you know this, you kind of figured that this would be the definition when you saw me talk about limits. You're about to write this down before I even showed you this, right? Just kidding. But this is a definition of a limit, and I want to mention a few things. One is a little review of beginning algebra, and that is the absolute value of x minus c. What's the geometric way of saying the absolute value of x minus c? What's the geometry of way of saying the same thing? Anyone know? This is beginning algebra, nothing fancy or anything. But you learned this maybe once, doesn't mean you remember it. The vector.
Maybe the hypotenuse, I don't know.
Shifted, not quite. It's a geometry word. It's kind of one word. It's an easy word. It's a word that even a first grader knows. Most kindergartners know too. The distance. So this says the distance between the number x and the number c on the number line is less than delta. Think of delta as a small number. So the distance between these, the value x that you're plugging in and the given value of c is very small. Okay. Then, and again, the distance, because that's the absolute value, between f of x and L is also very small. So it says that if the distance between x and c is small, then the distance in the x coordinates is small, then the distance in the y coordinates are also small. Does that make sense? Kind of helps, I think that might help you understand this definition a little bit, and that's why it's important. So if the distance between x and c is small, that's the same thing as you're really close to that spot where you're trying to meet. And the distance between f of x and L is small, saying that if you're really close to that spot that you're trying to meet, then you're going to be really close to the limit. And that's the idea of the limit. Any questions on this definition before I kind of give you a visual? Okay, let's do a little visual. And this is something I found online. And there's a little exploration. Unfortunately, you can only do this one example. That's okay. Just some cubic or something. So the idea here is that we set x. So right now I have x as 1.5. Okay, so there's my value of x. And then we're going to set epsilon. In fact, let's do this now. So if let's say epsilon, we're going to make it pretty small. How about 0.3? Okay, so that means that epsilon is 0.3. So that means I want to make sure that I don't go farther than 0.3 away from the y value on the curve. So right now I have delta too big. So epsilon was given. Epsilon's always first given. So in this thing, we have x is given, epsilon is given, and then you get to choose the delta. And epsilon is given as 0.3. So that means we got to make sure that we're close enough so that we don't go farther than 0.3 up and down from this dashed line. Okay, unfortunately, if we let epsilon be 0.63, then we got points over here that's way farther than 0.3 from the dashed line. Do you see that? So this delta is 0.63 doesn't work. Is that clear? All right, but I like to call this the epsilon delta game. And the idea is the way the game works is that the competitor, that's not you, has to choose epsilon first, and then based on that, you get to choose delta. So you get to be small if you want. Smaller is always better. So let's choose delta to be much smaller. Okay, now I set delta to be 0.04. Notice that in this blue region, now we have points on the curve, and every point on the curve in this kind of bluish purple region is within epsilon of the dashed line, is within 0.3 of the dashed line, up and down. Because all of those points made it in this kind of, what is that, orangish area. Anyone lost on the picture idea? Okay, so this is an example where the limit exists. Okay, unfortunately, it doesn't show one that doesn't exist. So, but it's a nice visual. If it doesn't exist, then you might, like for example, if there's a jump discontinuity, then you're gonna have something up here and something down here. And no matter how close you get, how small you make delta, you're always gonna have points that are far away from each other. And so if you pick an epsilon, if your opponent picks epsilon that's smaller than how far that jump is, you're not going to find a delta that works. Any questions on this visual? Okay, and I want to give you a major warning. It's a lot easier to watch the visual than to do a formal proof. Okay, formal proofs are hard, but we're going to do some. Okay, so are you ready for some formal proofs? So let me go back. And first thing, let me actually, I want to start a new page. There we go. Okay, so first thing, what do you think? Does this limit exist? The limit as x goes to 3 of 2 minus 5x. Does that limit exist?
Yes.
Okay, it looks like it. And if you think it exists, what do you think it is? That's the first thing, is we need to guess what it is. I hope this is easy for you. Yeah, so negative 13. Okay, so if all things are good, this limit should be negative 13 because you just plug in. There's a line, right? 2 minus 15, negative 13, looks wonderful. Is that a proof that this limit exists and it's negative 13? No. So this is not a proof. So let's go for the proof. All right, I will let you know that every epsilon delta proof to show that you have a limit starts exactly the same way. And let me remind you the definition. For any epsilon greater than 0, that's how it starts, right? So in the proof, we're going to say let epsilon be greater than 0. Any questions so far? So I'll let you know that's not the hard part. Okay, but that's how we have to start, because that's how the definition starts. Is that it? Again, we're looking at that game. Someone has chosen an epsilon, and now we got to come up with a strategy to find delta so that the inequalities work. Any questions on that idea? Okay, so to let you know, what I'm going to do is I'm going to put some space in between the limit and the proof, and I'm going to do scratch work. It's not part of the proof. But if you don't do the scratch work, good luck. You're never going to be able to figure out the proof. And this is one of those, any of you guys ever play with mazes? You know, good old maze on a paper. If you want to, if it's a really hard maze, what's the strategy that usually works to figure out a maze? Start from the center. Yeah, work backwards. Work backwards. So what we're going to do, and then eventually you got to go forwards. But you work backwards to give you an idea of what you need to do, and then you go do it. That's exactly what we're going to do with epsilon delta theorems, with epsilon delta proofs, is we're going to work backwards. Let's go back to the definition. We need that the absolute value of f of x minus L is less than epsilon. That's our conclusion, right? That's the end of the maze. So I'm going to start with that. I'm just going to copy and paste it, so I'm going to have to do all this mess. Then I'll have to change the font or the size. So on the scratch work, we're going to start there. Okay, now we're going to substitute it in. So now what we can do is we can write down what these things are. Well, we have the absolute value. What's f of x?
Two minus 5x.
Good. So 2 minus 5x. And then minus L. What's L?
Negative 13.
Good. Negative 13. And the absolute value. And we need that to be less than epsilon. Any questions so far? All right. Hopefully you could do this arithmetic and algebra in your head. What's 2 minus 5x minus negative 13?
Three.
Well, it's not a number. X could be anything, by the way. Don't try plugging in a value for x. How do you simplify 2 minus 5x minus negative 13? Very close. But notice that 2 minus negative 13. Good. Negative 5x plus 15. So what we can now write down is the absolute value of negative 5x plus 15. And yes, you are responsible for knowing basic algebra. Less than epsilon. Any questions so far? Okay, let me show you something in definition again.
It's not really a question, but Larry, did you say the L is yet the whole equation is absolute value, or the L? Because you just wrote negative 13. Isn't that?
Maybe I'll
Wouldn't
make
it
it
be plus?
spacier.
Yeah,
It's
there
a
you go.
minus -13.
Okay, yep, gotcha.
Yeah, yeah. Or I could throw it in parentheses if you want. Yeah, that's all that is. It's a minus L minus -13. Got it?
Yeah, the space.
Okay.
Just looking at it real quick.
Yeah, the space helps. Otherwise, it just looks like a long minus sign. Okay, so now I want to go back up to the definition. I need to find delta. Remember, it's like a game. Someone gave us the epsilon. Now we need to come up with how do you find delta? So now we need to end up with x minus c less than something. Any questions on that? So c is 3. So we need this to be x minus 3 and not negative 5x plus 15. What can I do? Algebra-wise? Divide, okay. Let's factor, not divide for now, but let's factor. And I'm gonna factor out a -5. Y'all want to divide by 5, I think, but it's a -5 because we need an x, not negative x. So I'm gonna factor out a -5. So again, all this is scratch work, but the scratch work is everything. And I can go absolute value of -5 times x minus 3. I'm getting there, is less than epsilon. Okay. Now, what is the absolute value of -5?
5.
5. I can actually use a little rule of absolute values that the absolute value of A times B is the absolute value of A times the absolute value of B. I don't know if you know that rule, but you probably should. Okay, so that tells you, I can pull out the absolute value of -5, and that's just 5. So let's do some more. 5 times the absolute value of x minus 3 is less than epsilon. Remember, my whole goal is to get absolute value of x minus 3 by itself, because in the definition, I need an absolute value of x minus c. So that's my goal in my scratch work, is to get an absolute value of x minus c is less than something. So last step is divide by 5. Okay, so let's go divide by 5. And we get absolute value of x minus 3 is less than epsilon over 5. Any questions on this? Okay, I want to mention something on the scratch work. Each of these lines that I have written down are equivalences. It means that if you have one, it means you have the other one. Is that clear? So if it's true, for example, that absolute value of -5x plus 15 is less than epsilon, then it's also true that the absolute value of -5 times x minus 3 is less than epsilon, but vice versa works too. If it's true that the absolute value of -5 times x minus 3 is less than epsilon, then the absolute value of -5x plus 15 is less than epsilon. So it's the maze idea, is that we just work backwards and then we're going to go forwards. So now what we're going to do is we are going to basically write down what I just wrote down in reverse. So the first thing I'm going to say is, well, again, in the definition, I have the absolute value of x minus 3 is less than epsilon over 5. I want the absolute value of x minus 3 is less than delta. So guess what? Here's how the game works. If someone gives us an epsilon that's greater than 0, we're going to let right, then let delta equal epsilon over 5. Any questions on this so far? That should be then, not the. Any questions on this piece? So just to let you know, usually with epsilon delta, the hardest part is to come up with this, what delta needs to be, epsilon over 5 in this case. Okay, and this is like the easiest example you can imagine, or one of the easiest. Okay, now what I'm going to do is now I need to go back to the definition. In fact, maybe I'll even copy and paste that so I know my goal. Copy and paste that, keep it in big, bright, big red. There's our goal. Our goal is to say if x minus c is less than delta, then absolute value of f of x minus L is less than epsilon. So it's right now. If the absolute value of x minus c is less than delta, not in big red anymore, then just put it in the chat. Okay. Yeah, if you're having trouble with Zoom, one idea is to log off and log back on, see if that works. So just a note, someone's having issues with Zoom. So that's one idea, is to try logging off, log in. Okay, so then what I do, again, I'm doing this maze backwards. Well, I substitute in. C is 3, delta is epsilon over 5, so I can copy and paste this guy. Thus, well, guess what? I can multiply by 5. Again, all the work's done for us. I'm just copying and pasting away. Hence, I love putting these extra words in. They all mean the same thing. Well, if 5 times x minus 3 is less than epsilon, okay, I can say that's the same thing as saying that absolute value of negative 5 times x minus 3 is less than epsilon. Those are equivalent, right? Okay. So it follows that. And now we can, basically what we're doing now is we're multiplying the negative 5 through. Therefore, and we multiply the negative 5 through, but now we could take that negative 5x plus 15, and guess what? Turn it into two minus 5x minus negative 13. Right? So the idea is, if you don't do the scratch work, good luck. To start with negative 5x plus 15 and know, I don't know what happened to the epsilon, less than epsilon. There we go. And to know to turn that into 2 minus 5x minus a negative 13, good luck. Okay, no, I doubt any of you, and I'm not either, clever enough to come up with that idea. So we can conclude that. And guess what? Now we're here. We're at our goal. Because 2 minus 5x is f of x. Negative 13 is L. And we've arrived at the goal in red. Okay, again, you do the maze backwards with scratch work, and then you go forwards and you arrive and you finish the maze. Okay, so we have proven that now we truly go back to our whole big goal, which was right here. The limit as x approaches 3 of 2 minus 5x is equal to negative 13. So I want to stop. Are there any questions? Are there any questions about this proof? I will let you know, I got creative just because, I don't know, I think I get bored otherwise. You don't have to say thus, hence, it follows, therefore. You could use thus for each of these, that's fine. I just figured I'd have some fun and write down. The good thing about English is there's lots of synonyms for all kinds of things. Any questions at all on this proof? It's a lot of work, isn't it? It's so much easier to just look at it and say, hey, it's 2x minus 5. I plug in, I got negative 13. There, the limit exists. That's not a proof. Okay, this is the proof, period. Okay, this is the proof. And that's what you have to do. Any questions at all on this example? Okay, now, again, it's not that hard to watch me do it. Do you agree? But doing it yourself's hard, and I want to give you the other big warning. Lines are the easiest there is. Are there other things in math besides lines for equations and limits? Absolutely. So let's do one, and we'll see they get harder. Okay, what's kind of next after lines in terms of level of difficulty? In algebra?
Parabola.
Yeah, so let's do a parabola. And then you'll see. And all of a sudden, the creative algebra gets even harder. So now, an example. How about the limit? Oops. Limit. As x approaches, how about negative 1? How about negative 2 of x squared? Make it a little fancier. How about 5x squared minus 15? Or even better, how about minus x? That'll work. Okay, first thing, let's do the easy part. What do you think this limit is? Yeah. Wait. 22, there we go. Don't forget, it's a minus minus. There's that minus minus thing going along. Okay, and what we want to show is that this is equal to 22. Any questions on that? Okay, so what we want to do is we want to do the scratch work. And in fact, I'm going to just pop on up to remind us how we did the scratch work before. We started out with this line right here. F of x minus L is less than epsilon. That's the scratch work always starts there because that's the goal in the definition. That's right, scratch work. Whoa. Here, good. Start there. And now let's continue on. So f of x we're going to have the absolute value, and f of x is 5x squared minus 22. Sorry, 5x squared minus x. L was 22. Is less than epsilon. Any questions on that? Okay, what's the next step? Starts with an F.
Factor.
Factor. Okay. Now, that one of the nice things about calculus is that, you know, you could try AC method or diamond, and 5 times 22 is 110. And you're like, oh. Or you could cross your fingers and hope everything works. Because what we want is we want x minus c. So let's hope it works, and then we'll check. And if it doesn't, then we cry. So we have an absolute value, and if it works, then it's going to have an x plus 2. So for this to work, we need a 5x to make it a 5x squared. And then we're going to need a minus 11 to make it a 22. And then you can quickly FOIL and see if that worked. And we get, if you FOIL that the outer and inners are negative 11 and 10, and you get negative 1, and you smile, it did work. Any questions on that? And that needs to be less than epsilon. Is that clear? Okay.
So just to double,
Mhm.
so the x box 2 is because the limit x is approaching -2.
Yeah, so x minus negative 2 is x plus 2, right? Because it's always x minus c. And that's in the big goal, x minus c less than delta. So here's the good news. Why do you need an x plus 2? You need an x plus 2 because that's your goal. X minus c is less than delta is our goal. Always focus. If you lose track of your goal, you'll never get there. Does that make sense? All right. If I asked you for directions, you know, can you give me directions on where I'm going this afternoon? What do you think? How many of you are going to give me directions?
Nope.
Not a chance, because I didn't tell you my goal. Okay, if you don't keep the goal in the front of your brain the entire time, this isn't going to work. Okay, a wonderful piece of good news is that whenever you have a polynomial and you're doing a limit and you're doing the scratch work, the x minus c will always factor out. So this is guaranteed to work. Okay, yeah, so sometimes there's good things in life, okay? Especially in a day when we're doing epsilon delta, and that's a tough day. Okay, so now, again, we need the x plus 2 by itself. Notice, by the way, we're taking a limit as x approaches -2. So x is close to -2. If x is close to -2, 5x minus 11 is negative. So that means, and we're going to pull this out of the absolute value, and it'll become an 11 minus 5x. It gets multiplied by -1, when you have an absolute value of a negative number. I can write this as the absolute value of x plus 2 is less than epsilon over 11 minus 5x. Was that too much algebra at once for you guys, or do you see what happened? So I divided by the absolute value of 5x minus 11, and then realized the absolute value of 5x minus 11 is 11 minus 5x. Any questions so far? So far, so good? All right. Here's the problem. You're not allowed to have an x on the right-hand side. And we have one. Is that clear? So what we can do is we can say that x, we know, is going to be close to negative 2. Any questions on that? And if x is close to negative 2, 11 minus 5x is close to what? 21. Is that clear? So in particular, 11 minus 5x is bigger than 20. Is that clear? And it's smaller than 22 because it's close to 21. Okay? So we're looking at epsilon over that number, right? We want our delta to be really small. So we're going to let delta equal epsilon over 22. Okay, and the important thing is epsilon over 22 is less than epsilon over 11 minus 5x.
Wait, Larry, why is it 22? Wouldn't it be 21? That's where I'm confused.
Okay, so delta could be whatever we want it to be.
Yes.
So we want delta, kind of the goal is you want delta to be small. It's never harmful to get even closer to the point when you're taking the limit. Delta is how close you get to the value on the x coordinate, right?
Mm-hmm.
So I'm going to let it be even closer. Because if I let it be epsilon over 21, I got a problem. I'm not going to have a less than, I'll have a less than or equal to when I'm done.
Okay.
So this way I actually get a strict inequality. So that is going to be less than epsilon over 11 minus 5x. And that's how I have gotten out of the problem of having an x. Any questions on that? Okay, so now.
Yeah, did you choose going up by a value of 1 arbitrarily?
Yeah, I could have gone up by 0.1. That's fine too. So in the scheme of things, epsilon and delta are tiny, tiny, tiny numbers because we're taking a limit as we're approaching x equals negative 2. Do you see that? So we can assume that we've gotten really close already. And so I chose 1 because 1 is a whole lot bigger than a tiny, tiny, tiny number, right? And 1 is also like the easiest number that's bigger than a tiny, tiny, tiny number. So that's why I chose it. And the idea is you can always, again, it's a game. Someone gives you epsilon, you get to choose your delta. Smaller is always better, right? So, you know, I could have chosen this to be epsilon over 21.1. That's even better, but a little messier, and it'll still work. Any questions? But if I chose delta to be epsilon over 20, it won't work because the inequality is backwards. So that's why I chose 22. Okay, we're ready. So now for the proof, because that's our goal. So that was scratch work. Now we're ready for the proof. And the idea is, what's the first few words of the proof? Always, in every single epsilon delta proof. And I told you, that was the first few words of the last proof.
Let epsilon be greater than 0.
Yeah. Let epsilon be greater than 0. And that's how all epsilon delta proofs work. Then we're going to choose. Okay, so you can think of your opponent just played the game. They gave you the epsilon. Now we need to say, okay, now how are we going to choose it? We're going to choose delta. To be equal to epsilon over 22. Which is less than epsilon over 11 minus 5x. Again, we're doing the math backwards now, right? Now we're forwards. We started backwards, now we're good to go forwards. Okay, so choose delta equal epsilon over 22, which is greater than, let me just copy it. That's right, which is less than epsilon over 11 minus 5x. We've already established that. So if, and now we write down always the beginning. In fact, let me copy and paste our goal again. So there's our goal. And actually, let's do a bunch of spaces so I don't change pages. There we go. So then if absolute value of x minus c is less than delta, then, and now we just go backwards. And this is where it's actually easier to do on a computer than it is to do in handwriting because I can copy and paste the whole thing. Then that, and I'm going to be less creative. I'm just going to use thus every time. So thus, so again, we were on that line. Now we can go back on this line. Basically, you multiply by 11 minus 5x, but you can put in 5x minus 11 into the absolute value because you're always allowed to do that with absolute values. Thus, and then we can multiply through. And if you multiply through, we get 5x squared minus x minus 22 is less than epsilon. Therefore, our goal is complete. There we go. So we can conclude that the limit as x approaches -2 of 5x squared minus x equals 22. Just a note, I'm going to write something down just for fun. QED. Have you seen that before? Anyone know what it means? I don't see y'all jumping in. Okay, it's Latin, yeah, but it's like what everyone uses in math when you're finished. Quid eris demonstrata. And then it's kind of a joke, but it's what a lot of people say. Quite easily done, even though it wasn't easy. But quid eris demonstrata is a Latin way of saying I'm finished. Is I've demonstrated the proof of this theorem that I was trying to prove. That this limit exists and is this number. Any questions? Any questions at all on this example? Okay, by the way, what do you think would be the next piece? You know, what if you had to do something with like, I don't know, sine of x? So the limit as x goes to pi over 3 of sine of x is root 3 over 2. What do you think? What do you think that would take? Yeah, more than a lot, by the way. 3 years of mathematics. We're not going there. So just let you know, something as easy as sine of x is not easy. To prove these things that are, you know, more advanced, full epsilon delta proofs are tough. Okay, so I will guarantee that we're not going to have to do anything that's like sine of x, but I do want to do one. So prove that if f of x is equal to, and I think I got to do it. Maybe. And then will it let me do it? Well, maybe not. Okay, so if the format looks weird, sorry. F of x equals, how about x plus 4 if x is less than 1 and x minus 1, how about x minus 3? If x is greater than or equal, that doesn't do it. X is greater than or equal to 1. Does not have a limit at x equals 1. All right. So again, if we plug in 1, 1 plus 4 is 5, 1 minus 3 is -2. So you can guess that it's not going to have a limit. That's not a proof, by the way. To prove it, you have to show that that there is an epsilon that can be given at which no matter what delta greater than 0 you find, it's never going to work. Any questions on that? And the idea here is that, again, I plugged in I plugged in 1, I got 5, and I got -2. Those are 7 away. So let's let, all we have to do is let epsilon be small enough so you're not going to get an interval of length 7. So let epsilon equal 3. Then if I go up and down, I'm not going to get to a length of 7. Okay, so what's the problem? The problem is if no matter what delta you choose, x plus 4 is going to be close to 7, and x minus 3 is going to be close to -2. Any questions on that? Okay. Yeah, just so you know, I never, I don't take roll. So I go a little, today's a hard day, so I'm gonna have to go a little later than normal. But yeah, so I don't take roll. And this is, it'll be recorded, I hope, as long as a disaster like 2 days ago doesn't happen. I don't know until it gets emailed to me. So anyway, if epsilon is equal to 3, then the idea is you're either gonna be close to 7 or you're gonna be close to -2. Any questions on that? Okay, so if the limit L was, so again, you have 7, you have -2, and the midpoint of that is what? 2.5, right? Was larger than 2.5. Okay, then for any delta greater than 0, so now the idea, if we're larger than 2.5, let's go to the high side and we'll do x minus 3. Then above, then how about then 0.1? How about even better? How about x 3? Sorry, 3. Not 1 is what I want. 1 plus delta over 2. We'll evaluate to larger than what? Sorry, x minus 3. So now if we're bigger, so for any delta greater than 0, if x is larger, so it'll be smaller than, not larger than. Well, smaller than what number? Smaller than 1. Because if you take 1 plus a small number and subtract 3, you get a number smaller than 1. Do you all agree? Any questions on that? Smaller than, sorry, -1 is what I want. There we go. So f of x minus L was 2.5, will be bigger than 3 in absolute value. Any questions on that? because L is bigger than 2.5. F of X is smaller than 1. So we're more than 3 away. And that's bad, right? Now I'm running out of time, but I will tell you, you basically do the same thing. I'll just say it. If X is smaller than 2.5, okay, then we look at the other side. Okay, then we go below 1. And then if we're 1 minus delta over 2, then we're going to have an X plus 4, and that'll be farther away than 3 from 2.5, because 2.5 plus 3 is 5.5, but 1 plus 4, if we have X plus 4, and we plug in 1, you get 5. Do you see that? So the idea is on either side, you're going to have bigger than a farther distance than 3, and therefore the limit does not exist. Again, I don't have time to work this all out because I need to mention 2 more quick things. I only have so much time. So note that we want to talk about left and right. So for the left limit, the only difference is you just have to make sure that it's the same definition. But restrict X to the left of C. Any guess for the right limit, what you do? It's the same definition, but restrict X to the right of C. Okay, so if we want to say the limit as X goes to 5 from the left, that just means that instead of X, when you say X minus C is less than delta, you say X minus C is less than delta for X less than C. If it's from the left, X greater than C from the right. That's all that is. There's not much there. And for infinity, to define the limit as X approaches infinity, then you just have to make sure that your final absolute value, f of X, minus L. Well, you can't do a minus L if it goes to infinity, right? So f of X needs to be really, really big. So it just needs to be greater than, let's call it N, for any given N. So instead of epsilon, you use N, because we want to think about X being big instead of some distance being small. And then the definition is the same. I don't have time to go through a bunch of examples. You can look at the book. I can only do so much. If you decide to be a math major, you'll take a whole, not just a course, you'll take a whole year of this, Epsilon delta. Okay, it's a big deal. But if you don't, then this will be the last time you ever see it, probably. So we are out of time. Normally, I'd be going into my office, or let me close the share and let me stop the recording.